let's see how you did on your practice problem with these new strategies that we learned about. Our problem says that the element europium exists in nature as two isotopes. Europium-151 has a mass of 150.9196 atomic mass units, and europium-153 has a mass of 152.9209 mass units. The average atomic mass of europium is 151.96 atomic mass units. Here we want to calculate the relative abundances of the two europium isotopes. So, like we said, we'll set it up like any old average atomic mass problem. So, we have europium 153 and europium, that was supposed to be 151, and europium 153. I usually do the percent abundances next, so I'll skip those. We multiply those by the respective masses. 151 has the mass of 150.9196 and 153 of 152.92. 0.9. The answers to those will add up to equal 151.96. Okay, so what do we do here? Well, we know that these abundances here, when we multiply them, should both add up to equal 1. Let's assign them variables. We'll call them x and y. So, we also have two more variables. We'll call these a and b. Now, like we did before, since we have variables, let's set up some algebraic expressions. We'll start with the simple one here. We know that x plus y equals 1, right? We also know that we have an expression here. 150.9196x equals a. Should we know that's a? Oh my gosh, that's a horrible a. Let's fix that. We'll do a more traditional a, so it doesn't look like another number. And we'll do the same type of expression below with y. We know that 152.9209 y equals b. We know that a plus b equals 151.96. Now, combining systems of equations can get a little tricky sometimes. So, what we want to do for a minute is to step back and look at the big picture. What exactly are we trying to solve for? we're really trying to solve for x and y. So the first variables that we should try to eliminate entirely are a and b. And that's not too hard if we look at the big picture. Well, a plus b equals this. And we already have two different equations that include x and y that equal those two things. So let's substitute in this for a and this for b. And we've eliminated a and b. I'll write those below. Now, we can kind of, essentially, forget about these right here and focus on this equation and this equation. What we want to do is we now want to get an equation that isolates one of these variables, x or y, and solve for that variable. Once we have that one variable solved, we can then plug in the answer for that variable back into the equation and solve for the other. I think the simplest thing to do is to just subtract away y from both sides here. And what we end up with is x equals 1 minus y. Now what we can do is wherever there's an x, we substitute in 1 minus y for it. That happens to be right here. So we can simplify the expression. Now what this does is it allows us to complete this algebraic expression, getting y by itself and solving for y. So let's follow through with the algebra that we know and solve for y. The first thing that I'm going to do is distribute in this into both of these here, following the distributive property. So I'm going to do 150.9196 minus 150.9196y plus 152.9209y equals 151.96. Let's zoom in on this a little more so we can see what we're working with. Let's move it over a little bit more too. we still need to work on getting y by itself. So the next step is to logically subtract away this number from here and get it on that side. So negative 150, or minus 150.9196 minus 150.9196 gets it away from there. Pull out my calculator. Don't want to mess that math up. Let's see how many sig figs I've got here. I'll line them up right. Leaves me with 1.0404 there. Let me rewrite this, make it a little neater. Okay, still need to get y by itself, but I can remove that by factoring it out. Take y out, I'm left with y times negative 150.9196 plus 152.9209 equals 1.0404. 3 sig figs. I'll do my math there in the parentheses. Gets me y times, let's sig figs. I didn't do it vertically. Let's see. 1, 2, 3, 4 there. 1, 2, 3, 4. So I'll have 4 after the decimal. 0, 0, 1, 3 equals 1.0404. Now, it's a matter of division. Move it up. Divide both sides. And I have my value for y. .0404 divided by 2.0013, which is 0.51986209 to 3 sig figs. Now, that is one of our isotopic abundances. Shrink that down. Take that value, whoops, gotta get my pen back on here. take that value all the way up to our original equation here, and we're just subtracting it from 1 to get x. 1 minus 0.5198 6209. That was 3 sig figs. Number 1 is infinite here. We have 0.4801. That's all I need to do because this will stay the same. So, x being this value here is 48.01% abundant. Y is 51 point. I didn't do my sig figs right. 48.0% abundant, and 52.0% abundant. And there we have our answer. Quite a bit of work there, huh? Systems of equations can get complicated, to say the least. However, take your time, follow through with the algebra you know. It's distributive properties, factoring out some minor things, but this is as hard as they get, really. Go with what you know. Get your systems of equations written out. Look at the big picture. Find what you're solving for and eliminate the variables that don't matter first. And then carefully substitute. Carefully watch your math and your sig figs, and you'll get your right answer.